For this lesson, we're going to build on what we learned about matrices that were 2 by 2 matrices and finding their determinants, and then using them to solve systems of equations where there was 2 equations with 2 variables. Now we're going to build on that and do it with 3 by 3s, and we're going to be able to eventually solve equations with 3 equations, 3 variables, and able to apply this to technology so we can see how technology can speed up the process. So that's where we're going. Our objective is to be able to solve 3 variable and 3 equation systems of equations with Cramer's rule. So first of all, a review of how to do determinants. When we did 2 by 2 determinants, we took a matrix, we represented the determinant with lines. The answer to a determinant is a number in every case. And so what we'll do is we'll make this and we'll go down on the diagonal. So we multiply these 2 numbers, 4 times -1, and we subtract multiplying these 2 numbers. So 2 times 6. So you get -4 minus 12, which will give us a -16. So that's when you do a 2 by 2, is you go multiply the diagonal down and you multiply the diagonal up and subtract. Well, when you're doing a 3 by 3, like this one here, you have to do 3 diagonals down minus 3 diagonals going up. So 3 diagonals down minus 3 diagonals up. Now, in order to do that though, we don't have enough columns to make this happen. So the setup, this is kind of the key step, the setup is to repeat the first 2 columns. So when we have this here, how we'll set it up, and on this one, oftentimes I'll just do the extra 2 columns on the determinant right there. But just so we see it here, we're going to list these 3 numbers, 3, 5, -1, and then keep going, 2, -3, 0, and then 1, 4, -2, and then repeat the first 2 columns. So 3, 2, and 1, and then 5, -3, and 4. All right, let's raise that up a little bit. Now what we're going to do is we're going to do 3 diagonals down. So we're going to do this diagonal down this way. So notice I'll just draw the first one here. I'm going to do these 3. So this is going to equal 3 times -3 times -2 plus, I'm going to do this next diagonal, 5 times 0 times 1 plus, okay, and then I do the next one, -1 times 2 times 4. So notice by adding those 2 columns, we were able to get enough of the terms in to do those diagonals. Now we're going to go on the up diagonals and subtract each of these. So this will be going up like this. So we'll have 1 times -3 times the -1 minus, now I'm going to do 4 times 0 times 3 minus, and then I do the last one here, -2 times 2 times 5. Okay, so now once I've written all of those out, I go ahead then and multiply those. And when I multiply them, I get 3 times -3 times -2 is 18, plus 0, plus this will be a -8, When you multiply these, 1 times -3 times -1 gives me a 3. We get another 0 here. We multiply that, and then when you have the negative and a negative, I'm going to have negative 20. So subtract -20 when I multiply that together. Now I can combine all those together. And what I get is, when I add all those together, I get 27. So my answer for this one, this determinant, is just 27 by doing this multiplication. Let's do another example. So doing this one as an example here, again, I'm going to go and instead of writing it out, all of it a second time, I just like adding the next two columns. So 4, 10, and -6, 1, 12, and 0. And now I'm going to go ahead and do my diagonals down this way. So I'll go -4 times -4 times 12 times 13, plus 1 times 9 times -6, this next diagonal. And the next one is, I'm going to add this, -2 times 10 times 0. That's the first one. Now I'm going to subtract the going up diagonal. So start down at the bottom here, the 3 diagonals going up. -6 times 12 times -2. Subtract 0 times 9 times 4. And then subtract 13 times 10 times 1. You got to make sure you've got everything lined up well so you can get the correct diagonals when you do that. All right, now when we do that, we go ahead and do each of these terms. When I multiply this, I get -624 plus -54 plus 0, and then -144 minus 0, and then -130. I do those multiplications. And then if I combine those terms, I get -952. Now, these take a bit of steps, and it is doing it by hand. You do have to take a little bit of time, but you should be able to show the steps by showing the extra columns and showing what the diagonal multiplication gives you, both the ones that you're adding and then the up diagonals that you're subtracting, being able to show that work. But now we have a secret weapon that we're going to unveil. We're going to figure out how to do this on our calculator. Now what's nice about doing it on the calculator is that it can automate the process, and that's what technology can do for us. So if we bring up our calculator here, if you notice here on my calculator, okay, I've got a matrix spot here as a second entry above the x to the -1st power. So if I hit second and then this x to the -1st power, that brings up my matrix menus. I've got the names of them at the start, and I can do many different matrices. I usually just I oftentimes will just use A, maybe use B at times. You can go over to the math menu. Notice that we can do different things and in different techniques. You'll use these things with matrices in the future. We're interested in the determinant. That's the one that we'll be using. But we first have to edit our matrix. So what we want to do is put into the matrix, put into this what our matrix is. So these steps, again, when entering a matrix, you want to go second. You want to do the matrix key, and then go to edit. And select the matrix that you want to work with. Now, when finding the determinant, what you're going to do is you're going to be on the calculator screen first. Then you're going to go to second matrix. Once you're there, notice that on this, when you're on the matrix screen here, you want to be underneath the math menu. Okay, so instead of edit, we'll go to the math menu. And then you choose the first one where you're going to choose determinant, DET, for that. Okay, so what we'll do on this, for doing this, we're going to go ahead and we're going to edit a matrix here. We're going to enter one of these matrices. So let's start by going back and looking at this matrix up here. Just to see this, this was a simple matrix. 2x2s are easy to do just by hand. But let's see how we would do that on a calculator. So on this, we're going to enter this matrix in. So we're going to pick over at Edit. We're going to hit Select. Okay. Now it's asking you, do you have a 1x1, 2x2, 3x3? What are the rows and columns? So you enter how many rows? I've got 2 rows, and then I go with 2 columns, and then you enter the numbers in. So it actually asks you for the numbers. So I'm going to put in 4, then enter, then 6, then enter, then 2, then enter, and then -1. Now I've got my matrix. Make sure you hit enter after that last one so it enters into the screen. Now go to your calculator screen, so you hit second quit, calculator screen, go to the matrix, second matrix, and we want to do the determinant, so we select the determinant. Now it's asking determinant of what? Which matrix? You might have multiple matrices in here. So I'm going to go back to second matrix. I'm going to select my matrix A. I just have to enter it. It's telling me it's a 2x2. Hit that. I'll do the parentheses just to close it, though you don't have to. And when I hit enter, it does the calculation for me and gets me to my -16 answer. Now you might say, well, you don't need that for the 2x2, but what about this 3x3? Let's go ahead and look at what that would look like if we did that. So we're going to enter in, let's do the harder 3x3 here. Let's do this one here. So let's go ahead and go to our calculator. I'm going to go to second matrix. I'm going to edit number 1 here, the A matrix. I'm going to make it a 3x3. And now I got to enter over the top these numbers. So make sure you do that. Otherwise, it's got the ones that were in there previously. So I've got -4, got 1. Be careful when entering these because you put in a mistake and it will give you the determinant for what you enter, not what you're intending to enter. So make sure you kind of double check your entries. 9, and then -6, 0, and 13. Okay, and then hit enter to make sure you get that last one in there. All right, now double check it. Make sure you've got everything entered in correctly. One last time before you go to your calculator screen, second quit. I'm going to go to second matrix. I'm going to go over to math and get determinant. And now I'm going to go with the A determinant. So I'm going to go second matrix. Enter in, just hit enter for my A matrix. I close the parentheses just to be correct. And then I get my -952. So we can enter that in and have the technology do the determinants for us. You should be able to show your work, but you should also be able to, on certain problems, use your calculator to do it. All right, now we're going to apply this to Cramer's rule. Cramer's rule, remember, allows us to solve systems of equations, and where this can really be helpful is when we have a system like this that has 3 equations with 3 variables, maybe some decimals and fractions. Hopefully this can speed up the process and give us an option that will give us an answer a little bit quicker. So just a reminder, Cramer's rule is where we take the determinant of the X matrix, we put it over the determinant of the coefficient matrix. So I label it this way, and we'll talk about how to replace columns and where you get these from. We did that with the 2x2s in the last lesson. Now we're going to do it with 3x3s. The y one is going to be the y matrix, the determinant of it, over the determinant of the coefficient. Always in the bottom is our coefficient matrix. So we'll put this down here for every one of them. And for z, we're going to now have a z matrix where we'll replace the z coefficients with the constants. Now let's go ahead and calculate each one of ours here. Let's go ahead and write out the different ones. So I'll actually write out the matrix for C. The coefficient matrix is going to equal just the coefficients of this. 1, -1, and 1. Excuse me, not 1, but 2 is the coefficient of the top one. So just take the coefficients of the x's, take the coefficients of the y's, so 1, 2, and 1, and then the coefficients of the z's, -1, 1, and 2. Okay, and so those coefficients, let me just double check my numbers here. All right, and when you do this, remember, if you were to expand this out, you'd expand the first two columns, so 2, -1, and 1, 1, 2, and 1, and then you would do the diagonals this way, and add the diagonals going down, subtract the diagonals going up. And if you were to do that, you would get for this coefficient, these coefficients, you get 8, so 2 times 2 times 2, plus 1, plus -1 times -1 times 1 is just 1. So you get those, and then you're going to subtract off this way. 1 times 2 times -1 is -2. Subtract 1 times 1 times 2, which will be another 2, and then subtract 2 times -1 times 1, which is -2. So you get those values. When you calculate that, you end up getting a 12 for that. So my coefficient determinant is 12. Now, to do the x matrix, all you do is you list the second columns as is. The 1, the 2, and the 1, the -1, the 1, and the 2, those stay. The y and the z coefficients stay put, but the x coefficients come out and these constants go in their place. So 2, -0.5, and then 3.5, and then you're going to calculate this determinant. You're going to go ahead and do the calculations, and I'm going to say that just repeating this process, you go ahead and get m sub x is going to be equal to 6. So what's our x value for this? X is going to be equal to the 6 over the 12, which gives me a 1/2. So I get the x value by putting the M matrix determinant over the coefficient matrix determinant. Let's do the other ones just to finish the process. So do the y matrix determinant. So I go back to the coefficient one, I just list the x coefficients here, I list the z coefficients, and then I put into the y column, I put the constants here, which will be my 2, my -0.5, and my 3.5. Those are the constants back up here in the original that go in the y spot. When I do those calculations, again, you can do that on your calculator, or you do it by hand by doing the down diagonals and the up diagonals. The y, you get a -12. So my y solution will be this -12 over the coefficient matrix determinant, which is 12, so I get -1 for that one. And then we go ahead and do the z1, again using your calculator if you'd like, or if you have to do it by hand. List the x by alone, keep the x column, keep the y column, 1, 2, and 1, and then relist here the constants, which are going to be 2, negative 0.5, and 3.5. And then you do the calculation for those, and turn in your calculator, or by hand, and then you get that, and you get 24 for this one. And so our z answer using Cramer's rule will be 24 over 12, which is equal to 2. So my ordered triple, that's a solution to this system, is 1/2, -1, and 2. So in summary, what we have is we first of all learned how to do determinants, extending it to 3x3 determinants. Then we learned how to do those determinants on the calculator. Once we have that, then we can use Cramer's rule to set up the determinants necessary, the coefficient matrix, the x matrix, the y matrix, and the z matrix, to solve 3 equation systems of equations using Cramer's rule by setting up our fractions and solving.